Infectious diseases are caused by pathogens such as bacteria, which can enter the body through the air we breathe, the food and drink we consume, or through openings in the skin such as cuts. For example, if an infected person with pneumonia coughs airborne droplets containing, let's say, the bacteria Streptococcus pneumoniae, which is the most common cause of bacterial pneumonia, when you breathe that bacteria, even one, you may now have the possibility to get sick with a pneumonia. Now you may wonder how one microscopic bacterium can have such a huge impact on the body alone. Well, the truth is, it can't. Your thinking is correct. That single-celled organism is too small to affect you by itself. But you have to remember what bacteria do for a living, which is consuming nutrients from the environment, growing to full size, and cutting itself in half to replicate itself and repeat. So the bacteria keep duplicating themselves until they can have an impact on your body. Then they all start producing their own virulence at once, which is why it takes a couple days of getting infected with the disease until symptoms will show. So how do these tiny beings know when to start producing their own virulence, or even do anything together? Well, they do it through the process of quorum sensing, their version of language. Bacteria have a chemical signal-producing protein and a chemical signal receptor protein. The signal-producing protein creates these small hormone-like organic compounds called autoinducers, while the signal receptor protein detects the level of autoinducers, which allows them to be able to sense how many of them they are, because as the population and size increases, so does the presence of these autoinducers. When the minimum threshold for these autoinducers are met, all the bacteria then instantly perform the group action. The group behavior can be lots of things like symbiosis, motility, sporulation, etc. So quorum sensing allows bacteria to behave as multicellular organisms and get the benefits to things that would be unattainable to them as individuals. Recent studies show that these autoinducers can be highly specific for species, as well as there being a universal quorum sensing language, which would allow bacteria to communicate within and between species of bacteria. For example, gram-negative bacteria use predominantly N-acyl homoserine lactone molecules to communicate to each other, while gram-positive bacteria use mainly peptides to communicate with other gram-positive bacteria, but both gram-positive and gram-negative use autoinducer 2 for interspecies communication. So the next time someone asks you how many languages you know, you can say you're a polyglot in chemicals.